Right, good morning, boys and girls. Good morning, colleagues. My name is Mr. Mpahama. You are welcome to this session. Today we are going to look at a graph of a cubic function. Of course, you agree with me that there is a lot of marks on this topic, especially calculus, that you must make sure that you collect. Right, let us start now because we don't have enough time today, only 1 hour 30 minutes looking at these functions here. Remember now, for all functions, it's very important that you know how to sketch, how to determine the equation, as well as the interpretations. Those are very, very important. Right, let us now start now with the graph of the cubic functions. Let us see now, what is it that is important here? First of all, now you look at this one. Now we have the standard form. We have the standard form. Of course, the standard form of a cubic function is f at x is equals to ax to the power of 3 plus bx squared plus cx plus d. Of course, that is the standard form. And then now these are the shapes of the graph. If a is greater than 0, then if the value of a there is positive, now the shape of the graph now will look like this one here. It means the graph will increase first. You can see here now the graph increase. We have the turning points, and now the first turning points that will come across there will be the maximum turning points, and thereafter the graph decrease and increase after. And then immediately when it increases, now we are going to have the minimum turning points. That's only when a is greater than 0. Of course, also you'll find that sometimes a is less than 0. If a is less than 0, then the graph, look at the graph, it decreases first. Now, if the graph decreases and then increase, of course, the first turning point will be what? Will be the minimum turning point. Of course, thereafter, now you are going to have the maximum turning points. Of course, the shape, you need to remember the shape. If a is greater than 0, what's going to happen? The function increase and decrease. The first turning point will be the maximum. Then if a is less than 0, the function decrease first. Thereafter, now we have the minimum turning point. Right, this is the shape of the cubic function. Of course, now let us look at the procedure for sketching the graph of a cubic function, which is very, very important, boys and girls. Of course, the first thing that you know, for all functions, x and the y-intercept are very, very important. But what's important is, what is it that you must do when you find the y-intercept? Of course, you let x to be 0. X must be 0 when you determine the y-intercept. And of course, for x-intercept here as well, you must also let y to be 0. F at x, g at x, h at x must be 0. That is number 2. And of course, now this one is very important. Now remember here now we'll be dealing now with what? With the cubic function now. Of course, first of all, when you solve for x, when you find the x-intercept here, what you must do first is you must find the factor of f at x. You must find the factor of f at x, of course, by finding the common factor. Always remember we say the same thing with the quadratic equation, finding the common factor first, or if possible, by grouping the terms together. There are 4 terms. Now on those two, if you group them together, now sometimes you are able to take out a common factor, right? Of course, now, if that one doesn't work, of course, you'll have to use a factor theorem. You remember the factor theorem? Yes, you must find that value that when you substitute it in the original equation there, it must give you what? It must give you a 0. Then we'll see that now is our x plus 1 or x minus 2 is our factor. That is a factor theorem. Right, thereafter, now number 3 there, we need to have what? The turning points. Boys and girls, this part here is very, very important. Very, very important. How do we determine the turning points of a cubic functions? Don't say x is equals to minus b over 2a. That one is for what? That one is for a quadratic functions. That one is a quadratic function. Okay, here what you must do first, you find the derivative. You find f prime of x, and then you let f prime of x to be 0. It means when you are finding the turning points of the cubic function, of course, you need to have the derivative, f prime of x, then you let f prime of x to be what? You let f prime of x to be 0, and now you solve for x. Right, we are still busy finding the turning points here. Of course, now once you have solved for x, now it means now the values of x that you obtained there, you will substitute those x values into the original equations to find the y coordinate of the turning point. It means from this one here, we will have the x coordinate of the turning point. Now, once you have the x coordinate of the turning point, you substitute x now in the original equation to find the corresponding y value. Right. Of course, boys and girls, now from these two, now you will have the coordinates of the turning points. Of course, we can state the nature of the turning points. Is it the maximum turning points? Is it the minimum turning points? Well, remember now, if A is positive, now you will see which one will represent the maximum and which one will represent the minimum. The same apply if A is less than 0, then you also see, because the function will start decreasing and increase, this side the function will increase and decrease. Okay, right from here now you can now be able to do what? You can now be able to draw now a smooth, curve. Of course, this is what you need when you sketch what? When you sketch a cubic function. So of course, boys and girls, I think before we find the equation now, I want us to look at this one where we sketch the cubic functions. Right, now how to find a point of inflection, of course, it's also very important here. You find what? You find the second derivative, second prime x. Can you see that one? You find second prime x, and now you equate it to 0. Thereafter, then you solve for x. You find the second derivative, you equate the second derivative to be 0, and then you solve for x. Good. Now the next one also, you can also use x is equals to minus b over 2a. Remember now this one, it means now you'll only going to apply this one in our first derivative. Second derivative, remember now we will be having from the standard form here. When I find the derivative, remember now it will be f prime of x is equals to what? 3ax squared plus 2bx plus c. Then it means this formula here, the one of x is equals to minus b over 2a, we are going to use it in our derivative, 3ax squared plus 2bx plus c. Then it means once you have the first derivative, once you have the x coordinates of the turning points, now you can use the derivative now to solve for x value of the point of the inflection. That is why we say use y is equals to f prime of x. Right, now sometimes you can also take the x coordinate of the turning point. You can also take the x coordinate of the turning point or the x-intercept of the parabola. Right, now you just add the 2, you divide it with 2, then you'll get the x coordinate of the point of the inflection. Of course, thereafter, now what is it that you're going to do? Then you substitute the x value into the original to find the y value. Right, boys and girls, now let us now look at the first part now, where we do what? Where we sketch this one. Of course, I'm going to take one of the past paper. Then we solve to see now, we try to apply whatever that I said earlier on with regard to the procedures for sketching the graph of the cubic function. Of course, let us look at this one together here. It says now question 1, that is November 2009. We are given that f at x is equals to minus x to the power of 3 plus x squared plus 8x minus 12. That is f at x is equals to minus x to the power of 3 plus x squared plus 8x minus 12. Of course, boys and girls, the first question there, they are saying we must calculate the x-intercept of the graph of f. We must calculate the x-intercept of the graph of f. Boys and girls, now I told you here, what is it that you must do when you do what? When you determine the y-intercept. Remember we said for you to find the x-intercept, of course you let f prime of x to be 0. Now you find the factors of f by finding the common factor first. If there's no common factor, you try first by grouping. And then if it doesn't work, then you use what? You use the factor theorem. Of course, it's a 5 marks question. Boys and girls, can I start first saying that, can you work on this problem so that at least I just see if you understand the procedures for sketching the graph of the cubic functions for about 4 minutes. Then immediately after this one, then we can do it together. Thank you, boys and girls. Let us see now what is it that we must do. What is the first thing that we must do here, boys and girls? Of course, we said when you find the x-intercept, we must let f at x to be what? Must let f at x to be 0. Then it means we have 0 here is equals to minus x to the power of 3 plus x squared plus 8x minus 12, right? F at x is 0. Now, of course, now, boys and girls, I can also make the a to be positive here. Remember, now we are having the equation. We are having the equation. I can divide each and every term here by what? By -1. The reason being, I want to make the coefficient of a there to be what? The coefficient of x to the power of 3 to be positive. Therefore, now we have 0 is equals to negative divided by negative is a positive x to the power of 3. Of course, minus x squared and minus 8x plus what? Plus 12, right? Yes, now I'm happy. Now a is positive. Therefore, you'll agree with me. Now, first, we need to have a factor here. Once you have a factor, the other one then will also be what? Ax squared plus bx plus c. Of course, boys and girls, now let us now try to see what will be the factor. What will be that number that when we substitute it here will give us a 0. Of course, we have x to the power of 3 minus alpha x squared and then minus 8x as well as positive 12. Then, of course, now I can say I want to start from where? I want to start from minus 5 will be fine, and also end at 5. That is your choice. That is the interval that you want to find those values. And now the steps 1, 1. Of course, now, boys and girls, we have the table here. From these tables, these are the x values, and this side we have the y values. Now, what's important is I must find 0 at f at x. If I find the 0 on this side, now I know that that value, when I substitute it in the equation, it gives me what? It gives me a 0. Minus 5 is minus 38 is not 0. Minus 4 is minus 36 is not 0. Minus 3 there. Minus 3, it gives me what? It gives me a 0. Very important. Now, it's not only minus 3, I believe. Minus 2 is 15. Minus 1 is 18. 0 is 12. And 1 is 4. And then 2 as well here is 0. Therefore, I know two values that when I substitute in this here, they will give me what? They will give me a 0. Now, what is the meaning of this one? It means x is equals to minus 3 here. Of course, we take this on the other side. X plus 3 now is we see now x plus 3 is our factor. Therefore, we can put x plus 3 here, or 1, because also when we substituted 2 here, then 2 we have y as a 0. One can also see now x minus 2 is a factor. Boys and girls, you must be very careful on this. Sometimes you'll be given to say, show that x plus 3 is a factor of f. It's very important, therefore, to show that x plus 3 is a factor of f, you just take minus 3, then you substitute it where? In the original equation. Therefore, if y is 0, then it means x plus 3 is a factor. Boys and girls, we have the first part here. Now we are looking for this one. We agree in this side we must have ax squared plus bx plus c. Yes, we must have ax squared plus bx plus c. Of course, boys and girls, there are many ways to solve this problem on this side. Others, of course, they are comfortable using long division method. There are many of them. Right, of course, let us see how can we find this one here. Of course, boys and girls, here I will put my factor here, minus 3. And now we take the coefficient 1 and minus 1 as well, minus 8 and positive 12. Right, boys and girls, 0 here. Why 0? Because you know that when you take minus 3, substitute it in there, we are going to get what? We are going to get y as 0. Right, 1 plus 0 is 1. Now we take minus 3 times 1 there. It is minus 3. Then minus 1 minus 3 is a minus 4. Negative 3 times negative 4. Of course, that will be what? That will be a positive 12. Then minus 8 plus 12. I also believe that that will be a positive 4. And you take minus 3 times 4. Then, boys and girls, the answer there will be minus 12. Can you see when I take a 12 minus 12 is 0? Yes, always when we get 0 here, it means now your calculations are 100% correct. Therefore, now I can say A is equals to 1, B is equals to minus 4, and therefore C is 4. Right, from here now I go straight here to say We have 0 is equals to x plus 3, and also these brackets here will be what? Will be x squared, because the value of a is 1. The value of b there is a minus 4x, and the value of c there is a positive 4. Right, now I have the 2 now. I have x plus 3 as well as x squared minus 4x plus 4. Of course, boys and girls, from here, I can now say, therefore, x is equals to minus 3, or then you factorize this one here. Factors here are what? X plus 2, no, x minus 2, as well as x minus 2 is equals to 0. Therefore, x is equals to what? Therefore, x is equals to positive 2. Right, boys and girls, these are the x-intercept of the graph of f. Remember, first, you equate f at x, y, h at x to 0. Then you look for common factor. If there's no common factor, you try to group the terms. If it doesn't work, now you must use the factor theorem. Right, boys and girls, let me say now, one now have decided to not to divide every term here by the negative. You leave the coefficient as a negative 1. Of course, it's very important, it's still the same. Right, what you must do there is that to say, of course, you have 0 is equals to what? Minus x to the power of 3 plus x squared plus 8x minus 12. Now, you have 0 is equals to minus x to the power of 3 plus x squared plus 8x minus 12. Right? It means from here, when you find your factor, you're still going to use the same one, but also x plus 3 will still be a factor, I believe. X plus 3 will still be a factor. And then from here now, we are going to have this one here, right? When I solve this one here, it means the coefficient now will be minus 1, will be positive 1, will be positive 8, as well as minus 12. Of course, the answer that I will get there will be minus x squared, will also be what? Will also be plus 4x, and this one will be minus 4. Right, boys and girls, what I want you to get right here is, of course, you can now say, therefore, x is equals to what? X is equals to minus 3. Or, sometimes, like we said, it's not easy to factorize, a quadratic equation if the coefficient of a is 1. Therefore, you can now say this is a minus x squared plus 4x minus 4 is equals to 0. Then now you can divide both sides by the negative to make it x squared minus 4x plus 4 is equals to 0. Right, now once you have it like this one, I believe now it will be easier for you to do what? It will be easier for me to factorize it. Right, boys and girls, I believe that you have this one right. Please, it's very important to make sure that you know how to determine the x-intercept of the graph. Right, now boys and girls, let us pass to the first question now, 11.1, where we had to calculate the x-intercept of the graph of f. The second question here, 11.2, now says you must calculate now the coordinates of the turning points of the graph of f. Right, what is important here is, what is it that we need for us to determine the turning points of the graph of f? Yes, so I can see now one is saying now we need to find the derivative. Of course, you are right. Once you have the derivative, now you let the derivative to be 0. Thereafter, you do what? You solve for x. Right. Once you have the x value, you take those x values, then you substitute them where? In the original equations. It's very, very important. Right. Boys and girls, also I think in 4 minutes time, then we're going to discuss this one. Make sure that you have the coordinates of the turning points. Right, thank you, boys and girls. Right, the question here says calculate the coordinates of the turning points of the graph of f, right? Yes, now what is it that you must do here? Like we indicated at the beginning to say, we need to take f at x. Now we find f prime of x, right? Now, what is f at x? F at x there, we agree with me that that is a minus x to the power of 3 plus x squared plus 8x minus 12. Now we find the derivative of f. Then the derivative of f will then be what? Minus 3x squared as well as what? Plus 2x plus what? Plus 8. Of course, the derivative of minus 12 there, the derivative of minus 12 it's 0. Right, the second step, boys and girls, is that you must let the derivative to be 0. You must let f prime of x to be what? Let f prime of x to be 0. Then immediately after this one, now we have 0 is equals to minus 3x squared plus 2x plus what? plus 8. Then from here now we solve for x. Of course, first of all, I will decide to divide everything here by the negative. We will get 0 is equals to a positive 3x squared minus 2x minus 8. Then from here now we factorize this equation. The factors are 3x multiplied by x would give us 3x squared. And now the factors of 8 is 2 times 4 or 1 times 8, right? But I believe that if I take 3 multiplied by 2, the answer will be 6. Then 6 minus 4, then the answer there will be 2. This is minus, and this one will be positive on this side. 3x plus 4, x minus 2. Our factors of 3x squared minus 2x minus 8. Now, therefore, now we can now say what? We can now say x is equals to minus 4 over 3, or also x is equals to positive 2. Boys and girls, now we have the x coordinate of the turning point. X is equals to minus 4 over 3, or x is equals to 2. Right, of course, you know how to determine the x coordinate. You find the derivative, then you let the derivative to be 0. Thereafter, you solve for x, right? Now we have the x coordinate of the turning point, right? What is it that you're going to do now to determine the y coordinate? Of course, we take the x coordinate minus 4 over 3, then you substitute it where? In the original equation where you have minus, then x is a minus 4 over 3 to the exponent of 3, plus, then also we have minus 4 over 3 exponent squared, plus 8 multiplied by what? Minus 4 over 3, then minus 12. Right now, what is it that you're going to have on this one? Of course, that is minus 4 over 3, then all to the power of 3, then plus minus 4 over 3, then squared, and then plus 8, then brackets there, minus 4 over 3, then minus 12. Then we have minus 500 divided by 27, which is, when it changes to the decimal, will be minus 18,5. Right, now we know that when x is minus 4 divided by 3 there, minus 4 over 3, then the y coordinate then will be what? Will be minus 500 over 27. Right, now we have the first one. Now the second one, you also do the same. You take 2, then you substitute it in the original equation. That will be minus, then 2 all to the power of 3, then plus 2 all squared plus 8 times 2 minus 12. Then the answer there is what? The answer there is 0. Of course, you can just work it out. It's 0. Why do I know that it's 0? Because this 2 is also the x-intercept. You remember here, the 2 is also the x-intercept. It means when you substitute 2 there, we are going to get what? We are going to get 0. Boys and girls, now we have the coordinates of the turning points. On this one here, we have what? We have a negative 1,3 as well as negative 18,5. And also the second one here, we have what? We have 2 as well as 0. Of course, you can look at this one now. Which one now? Because the graph of f now is decreasing. Why am I saying it's decreasing? The value of what? The value of a is less than 0. It means the graph decrease first. We are going to have the minimum turning points and increase after. Then immediately after that one, now we are going to have a maximum turning points. Right, boys and girls, from this one I can tell you now, this one will be the minimum turning points. This one will be the maximum turning points. Of course, let us see if this one is true now. 11.3 now they are saying now we must sketch the graph of f. We showing clearly all the intercept with the axis and the turning points of f. It's very, very important, right? Boys and girls, now I believe now we are left now with plus or minus few minutes. Of course, now can you just make a sketch of this graph of f? Then we can now see, compare yours as well as mine to see if you did it correctly. Right, thank you very much, boys and girls. Now, let us try to sketch the graph of f. Now, what informations do we need to sketch the graph of f? of course, we need the x and the y intercept. No, we need the x and the y intercept. Of course, the question here, we did not have the question that asks us to determine the y-intercept of a graph. It means looking at the graph, we know that when we determine the y-intercept, x must be 0, right? Then y here will be what? Y is negative 12. There is a negative 12. That is, y is negative 12. What is x? Of course, x is minus 3. Here is minus 3. And then y is what? Also, the other x here is a positive. X is positive 2. Now we have x as well as the y-intercept. Of course, now immediately after x and the y-intercept, now we must look for the turning points. You remember now the values of the coordinates of the turning points here. We have minus 1,3 as well as minus 18,5, right? Minus 1,3. Minus 1,3. Here is 1,3. Of course, with minus 18,5, that is 16, 18,5. 18,5 minus 1, minus 1, minus 1, minus 1. This is positive. Minus 1,3 is on this side. Sorry for that. And thereafter, now we have minus 18. Then it means now our graph then will be on this side. That is the turning point. Of course, most of the time I encourage learners to indicate, immediately now shows that this one here, you must indicate that this is a turning point. Of course, it must be concave, concave up. Right, now immediately after this one, now we have the second turning point there. What is the second turning point? X is 0, y, x is 2, y is 0. Then this one as well, it is of course the turning point. You can see now this one now will be the maximum turning point. Thereafter now, boys and girls, you now just to join this. You don't have to use the ruler to join this one, boys and girls. Yes, you're not supposed to use the ruler. Then we have the graph of f. There we are. Then, of course, you remember because 8 was less than 0, the function decreased first. We have the minimum turning points here, increase and decrease. Now, immediately when it changes from increase to decrease, then we have the maximum. Of course, they said that we must indicate the coordinates of the turning points, this minus 1,3 as well as minus 18,5. And this one here is 2 as well as 0. Y-intercept there we can see is a minus 12 as well as the x-intercept is minus 3 as well as 2. Right, boys and girls, this is very important, especially when we are determining the equation of this function here. Look at this one here. If you find that the x-intercept is also the turning point of the graph, you will see that that point it repeats itself, right? If the x-intercept is also the turning points of the graph, then the point also repeats itself. It means it was x minus 2 multiplied by x minus 2. I believe, boys and girls, your sketch or your graph is as smooth as mine. Please make sure that you don't use your ruler to draw the graph. Okay, right. We also indicated that we have 11.4 that says that write down the x coordinate of the point of inflection. Right, boys and girls, what is it that we must do here? What is it that we must do here? Of course, you remember now, our first derivative was we need to find the second derivative. Then it means we need first derivative, which was minus 3x squared plus 2x minus 8. Plus 8. This was our first derivative. Now let us find the second derivative. Of course, first f second prime of x is equals to, that is a minus 6x plus what? Minus 6x plus 2. Because just take 2 multiply by minus 3 is a minus 6. Then the derivative of 2x is a positive 2. Then you let it to be 0. Then 0 is equals to minus 6x plus 2. Then take 6 on the other side. Positive 6x is equals to what? Is equals to 2. Then I divide by 6 on both sides. Therefore, x is equals to 1 divided by 3. Please, boys and girls, look at the question. Here they said write down the x coordinate of the point of inflection of f. It means in this case you are only looking for x, right? But